Let's get the lights arranged. There we go. All right, let's get started. Welcome to week 4 of the Freshman Engineering Seminar. Semester's just sort of rolling along, isn't it? All right, so a few announcements. I know it's Friday, and I'm sure that as freshmen, one of the last things you probably want to do is be around a bunch of engineers on Friday night, but I thought I would mention this. There's a local organization called the Engineers Club of Huntington that meet monthly, and they meet usually through the academic year. Their first meeting is tonight at 6 p.m. at Sacred Heart Parish Hall. They actually used to meet at the Ponderosa, but I'm sure some of you are aware that actually closed down not too long ago. But they're a really good group of folks. They meet monthly to discuss and hear presentations on technical aspects of engineering. They also have a scholarship available here at Marshall to engineering students, so it might be something worth checking out. You know, I was actually speaking with a senior engineering student not too long ago, and he said, you know, when I was a freshman, this is probably the last thing I wanted to do, and now that I'm a senior, I'm marking it on my calendar. So it's a good networking opportunity, you know, possible scholarship opportunity, so it's something to consider. Okay, in addition, as college students, you all are always going to be in need of some supplies, some school supplies and whatnot. Theta Tau is conducting an engineering paper sale. I'm not sure if you all as freshmen are beginning to use that for your courses, but when you all get to your sophomore and definitely your junior and senior years, you're going to be burning through engineering paper like it's no tomorrow. Theta Tau is selling some. They're selling 1 pack for $6 or 2 for $10. That's a pretty good price. So if you're interested, contact Andrew Mays. There's his email address there. In addition, SAME ASCE is conducting a 3-ring binder sale. They got a boatload of 3-ring binders donated to them. So they're basically, they're in different conditions, so they're just sort of a name your price aspect. So if you're interested in getting some 3-ring binders for next semester or for your semesters to come, just contact Logan Stacks, and there's his info there. Now, the civil engineers and the mechanical engineers are engaging in a friendly competition. They're building a catapult on October 1st, I believe is the day, to see who can launch a particular object the farthest. Now, obviously, the civils are going to win, but see, okay. Getting the fires stoked a little bit. No, but they're going to have a meeting on Monday, September 19th. That's this Monday in EL 101. If you're interested in being involved in that, you might want to go check it out. Just something that's a little bit of fun. Now, on some housekeeping issues, I actually I had a typo on quiz 3, specifically on question 7. So what I'm going to do is I found out about it in the middle of the week. There was a student who notified me of it, and I didn't want to change the quiz midstream. So what I'm going to do is sometime later this afternoon or maybe tomorrow, somewhere, whatever, I'm going to adjust everybody's grades to assume they got question 7 right. So sound good? All right, just make that fair. Now don't forget, quiz 4 is going to be made available today, sometime later today, and it'll close, just like always, Friday at 11. Any questions about anything at all? All right. So real quick, just a few words about our speakers. So our main speaker today is going to be Bobby Burgess. He's out of J.H. Fletcher and Company. They're a local fabricating outfit here in Huntington, and they've been heavily invested in our engineering programs here at Marshall, so I'm definitely delighted to have him here today. But before that, we're going to have one of our faculty come in and introduce themselves. So our faculty this week is Dr. Chen. He's a mechanical engineering faculty here at Marshall, and he's going to tell you a little bit about his research and his experience and what he does here at Marshall. So everybody, let's give a round of applause for Dr. Chen. Is that? And then, well, I'll get it.
Oh, okay, thank you. Okay, thank you. So next one, I will press button.
You can use that.
It's left, right. Which one? Oh, which is, okay.
There you go.
Okay. All right. Good afternoon, everyone. My name is Chen. I'm an associate professor in mechanical engineering department. I'm going to talk about my background. I got my bachelor's and master's in Shanghai, in China, maybe 30 years ago. And I got my PhD in Asia, in Singapore. And before that, I once got a scholarship from the University of Cincinnati, not far away from here. I once got a scholarship from a university in British. Because of a lot of reasons, maybe cost-effective solution, I got my PhD in Singapore. And I have been with Marshall for 4 years. Before that, I taught in University of Alaska, Fairbanks. That is a flagship university in Alaska. And before that, I was a research scientist in Michigan, Detroit, not far away from here. Okay? And before that, I was a research scientist in California, Silicon Valley for IBM. And before that, I was in Asia, in Japan, in Singapore. I worked for Sony Corporation. And before that, I worked for Singapore National Lab. And before that, I was a lecturer. Maybe 25 years ago, I was a lecturer in a university in China. But that university, their mechanical engineering program has been ranked #1 in China. Okay, and some of you guys are curious about who I am, what do we do. We are too busy, and here the program is new, so we have a lot of time to build up our web page. However, if you go to Google, put my full name, Chen, you can find many of my background. Okay? I can share this kind of sense with you. Like if you are going to work for, if you are in the future, if you're going to get a job in Detroit, please talk with me. If you're going to get a job in high-tech area, like a micro system, you can talk with me. Okay, I've published recently about that. Okay, and I taught several courses in Marshall. Okay, and right now I teach machine element design. Design of machinery, and vehicle dynamics. And before that, I taught some fundamental engineering courses. And in the future, likely I'm going to teach the design of complex mechanical systems and also microsystems, and possibly like mechanical and structural health monitoring, working with Dr. Michelson. And that's about it. And currently my research is about the modeling, figure out the model and the simulation and the monitoring and the diagnosis of complex dynamical systems, including the machine, automobiles, engine, also microsystems, also could be some kind of a structure, and also like a kind of energy machine, like wind turbines. And my recommendation to you guys, here are several points. Number 1, hardworking. Number 2, resilience. And number 3, personal responsibility. And then number 4 is lifelong learning. So that's about it. Thank you very much. If you have any questions, okay, thank you.
All right, so we're just going to go ahead and keep this moving forward. So I'm going to go ahead and turn the floor on over to our main speaker, Mr. Bobby Burgess. Everybody give Mr. Burgess a round of applause. Almost forgot the mic. I'll get this loaded up for you. Okay. There you go. It's all yours.
All right. My name is Bobby Burgess. I'm a design engineer for J.H. Fletcher Company. I've been there since 2013. I graduated from the University of Kentucky in May 2013 and started at Fletcher on July 1st of that year. So I'm just going to start out kind of going over what Fletcher does. We're a mobile machine manufacturer. We primarily do machines for underground mining. Not primary market for the last 75 years has been the coal industry, but about 20 years ago we branched out into other types of mining, platinum, limestone, trona, salt. So we're anywhere you can underground mining something, you'll probably see one of our machines there. The majority of our machines are for underground roof drilling. So once you mine out the coal or whatever you're wanting to mine out, you've got to go back in and support the roof so that you can continue your advancement. So our machines are the ones that go in, drill the roof, put in the bolts, hold up the roof. So there on on the far picture there, that is actually a man-up bolter. So a man will stand in that basket and he'll drill a hole in the roof and put a bolt in. This here is a mobile roof support. So basically what it does, it holds up the roof while a continuous miner goes in, cuts out the coal, then it retracts out, and actually the mine collapses behind it. So it's meant to hold up the roof while you dig out your supports. This is our standard HDDR machine. So this is, if you walk through our plant about 5 years ago, about 80% of the machines you saw in there would be this machine here. Like I said, we service all types of mines. We custom design everything, so every mine you go into is different. So almost every machine you see coming out of Fletcher will have something a little bit different about it. So we design roof bolters, scalers, face drills, ANFO loaders, beam handlers, can stackers, long hole drills, mobile roof supports, and diesel tow vehicles. And that's just another HDDR over there with the guys working underground. So some 100 to 120 million bolts are installed in the U.S. every year, and Fletcher machines install over 90% of these bolts. That number is probably a little less right now with the coal market being down the way it is, but still the majority of the machines in the United States putting in bolts are Fletcher bolts, or Fletcher machines. This machine here is actually a remote drill, so instead of having a man up, it's all done remotely. So it drills a hole, picks up a bolt, puts in a bolt. It's actually a rather difficult problem to work on. So just some more machines. You can see the wide range of machines. Almost none of them look the same. That's kind of typical at Fletcher. So with everything being custom, there's lots of different engineering challenges every day for us. So I'm just going to kind of go over my responsibilities at Fletcher, what I do on a regular basis. The main number one thing is design machines to meet customer specifications. So salesmen, engineers will meet with the customers, will develop specs for their specific applications. We'll write a production order. When that production order is written, then it's sent to the engineers and we design the machines to that production order. So a lot of things that go into the design of the machine, you have stress analysis of your critical structures, so booms, canopies, TRS, which is temporary roof support. So we actually hold up the roof while we're drilling, and then after we put in the bolts, then you can bring down your temporary roof support. Sizing of bearing and pins, hydraulic cylinder sizing, so bores and rods based on your forces, stroke lengths are required to achieve, or length to achieve required motion. I work a little bit on the design of hydraulic systems. Don't do a whole lot of that. Prepare engineering drawings. That's a big part of what you do. After you design it, then you have to put it on a drawing so somebody can manufacture it. And then always provide engineering support during assembly. Yeah.
You mentioned bolts a lot. What are those?
Bolts?
Yeah.
Okay, so a lot of coal mines, we'll start with coal mining, is mined in like a checkerboard pattern. So what the majority of support is just a pillar of coal. But between the pillars, you have to support the roof. So essentially what you're doing is you're drilling a hole and then you're putting in a bolt with glue, and that's sandwiching all of that together, and so you're essentially creating a beam across the two pillars. So that's what actually holds up the roof so that you can travel safely beyond it. So bolts typically are just rebar with forged heads on the end. Some of them are mechanical inserts, so they've got a thread and a nut. So after your glue sets up, then you actually torque it, much like you would just a normal bolt. But I mean, these things are anywhere from 4 feet long to 12 feet long. So I mean, they're all different sizes for different mines, different applications. So kind of the first problem I was given at Fletcher was this Tram drive. The problem was our current collar drives were failing on a regular basis for machines weighing over 65,000 pounds, resulting in frequent rebuilds and costly warranties. So the project was to design a heavier duty crawler to provide a better reliability and life for larger machines. Many of our machines now are 80,000, 100,000 pounds, so we needed a new product to go on to these. So I was given requirements in the production order. Tram, 100,000 pound machine up at 25% grade, minimum speed requirement of 100 foot per minute, it needs a package to allow easy modifications of our current machine designs. So it's really easy to design something like this if it's, if you've got a room as big as this. It's a lot harder whenever you've got to get it into a coal mine that's only 5 feet tall. All right, so that's a lot of the problems we run into. You've got, the mine is 20 by 5 sometimes, and it's got to fit in there. So we want 450 miles total tram life, hydraulic pressure of less than 3,500 psi. So the first, go through the engineering process. So we develop the requirements, as I showed earlier. You lay out a possible solution to the problem. You analyze that solution to see if it actually meets the requirements. Then you just iterate. So you start all over. All right. So you come up with a solution, see if it solves your solution. If not, you start over. All right, or build on your previous solution. Okay. After you've done that and you meet all your requirements, you develop engineering drawing, and then you move on to manufacture, test, and then revise design to correct any problems or to make manufacturing easier, all that kind of stuff. So here you can see several iterations that I've gone through on this thing. Many hours spent on layouts, bearing analysis, gear analysis, all that kind of stuff, packaging. Finally, you come to a final solution. So this is the solution. This is an engineering drawing. This is just an assembly drawing. So there's not a whole lot of detail other than basically showing you what parts are involved. So each one of those parts will have their own individual drawings to show you how it's manufactured, responsible for developing all of that. So then you move on to testing. Design a test fixture. You use 2 drives connected by a chain. One was driving and one was driven. Leaf valve was placed in the outlet of the driven motor to create the load. All right, so you're actually back driving these to create torque. Excessive chain and sprocket wear caused by the wrong sprocket profile and a lack of clearance between the 2 sprockets. So just from the simple test, we saw a problem with it, and then we corrected it and moved on from there. And then final implementation onto our machine. You can see the crawler down there. All right, so the drive is right in there. So it's on the machine, it's out working in the field. We have had some field failures, so part of my job then is to figure out why they're failing and to fix those failures. All right, the next thing, this is another big project that I had. I actually just got back from Africa working on this project Friday, so it's actually going really well. But the problem was, the project was to develop they need a reliable production-ready roof bolter that allows the operators to remotely control the drilling stations. So this, typically, a lot of our machines are man-up machines. Most of our remote machines are not in coal mines. So this is actually for a coal mine. We haven't really done this before. We've done auto drills, but they're complicated. They're not very reliable. They're difficult to work on. So we were asked to develop a simpler machine that was reliable, basically. So it has the requirements where it has to use their bolts and resin, has to be able to meet the customer's bolting patterns while fitting the profile of their mine, be able to operate the machine from behind the last 2 rows of bolts, meet current production rates, and they needed a 16-bolt carousel. So here you can see CAD drawing, not completed, but of the machine. Okay, so we went through several iterations, like I said, to get to all of this design. And the majority of what I worked on were these booms and the module out here. So this right here, those are the bolts. So you drill the hole with this one, and then this indexes around and it inserts the bolt into the roof. Okay, so it's all done remotely from the control station here. So everything's hydraulically controlled. So kind of what goes into that, like I said, boom design. You can do stress analysis on the structural components. You can see here this is a FEA analysis of the boom. So you have a load, you put it on your boom, you have your supports, and you see what stresses are in your material. Your material is rated for a certain stress. You want a safety factor above that. So you keep iterating your design until you are under that safety factor, or actually above the safety factor, under a stress limit. Okay, cylinder sizing for loads and auto leveling of the bolt module. So actually the way this works, as this cylinder extends, this cylinder will extend at a relative rate. So as the bolt module goes up, it actually stays level. So that was all involved, figuring out that geometry and balancing areas of the cylinders, stuff like that. And then moving on to the bolt module, This was less about structural design and more about mechanical component design. As you'll see, a lot of you mechanical engineers later, you'll get into bearing analysis, gear analysis. So I had to do all that on this drive. So what this drive actually conveys this chain up, which pulls this drill head up. So it's just, as this thing rotates, it pulls it up, and that's how it drills into the roof. So a lot of bearing analysis, gear analysis, running through the numbers, trying to figure out, you know, I know my load, so then just going back through and making sure everything's sized correctly. So then you move on to assembly. Final assembly took place from November 2015 to March 2016. Much of my time was spent troubleshooting hydraulics and coming up with solutions to design problems. So this was the first time we'd ever built this machine. First time you ever build anything, there are going to be problems. So my job as an engineer is to figure out what those problems were. Okay, was it a quality issue? Was it a design issue? And or some other kind of issue? Has it been assembled wrong, hosed wrong, something like that? So then, once you figure out what the problem is, you have to figure out how to fix it. If it's a quality issue, okay, can it be reworked? Can you take it? Can you weld on it, grind on it? Can you make it work? Or do you have to reject it, order a new one? All those kind of decisions are left up to the engineer. So that's my responsibility to go in and figure that out. This machine, for a first machine, fairly happy, didn't have too many problems. Had some hosing issues that took us a long time to figure out, but overall went pretty well. So like I said, this is actually the machine above ground in Africa. They're getting ready to tow it underground. So I was there for 2 weeks, commissioning, helping train operators, making any final adjustments to the hydraulic system, and just basically monitoring the operations. Overall, the trip went well. The customer is extremely happy with the machine. So we're hoping to sell a lot more of these. So that it's been a good machine. So good problem, definitely challenged me. So just my advice, the basic thing: study, go to class, seek help if needed. Don't just copy the solution manuals. I'm sure you guys already have all of them. Don't get discouraged. Keep your engineering textbooks. Take advantage of networking opportunities while in college. At the end of the day, your goal is to find a job once you graduate. So starts early. All right. Don't wait until your last semester of your senior year to try to find a job. It usually doesn't end well. Get work experience before you graduate. I would say that every single one of you should take this to heart. If you want a job when you graduate, right as soon as you graduate, do a co-op, do an internship. I've had friends that didn't. It took them months to find a job, and a lot of times it wasn't a job they wanted. So go to career fairs, find co-ops, internships. I highly recommend it. Apply to as many jobs as possible. Sometimes your first job isn't going to be your dream job, but at least it's a job. Don't just rely on the university's employment resources. All right, there's lots of resources online. Go out, find what you want. All right, apply for the jobs that you actually want. I know this is probably a little early for you guys, but just keep it in the back of your head whenever you get to that point. And don't be afraid to make mistakes. It happens. You just fix them after you do. All right, any questions? That's all I have. Yeah.
How do they do the mining for you? Like, what is your machine?
So they have our machines in the mine. If you're talking like before, roof bolters have been around since the 50s. So before that, it was timber pillars. So they would actually build timbers and place them up, and that's what would hold the roof. So safety in mining over the last 50 years has greatly improved. Yeah.
What's the cost of some machines?
This one we just sent to Africa was like over $1 million. I think the most expensive machine we've ever sold is $1.6 million. A lot of our machines are in the $500,000 to $750,000 range. Yeah, so they're big equipment, expensive.
What kind of mining did you guys do?
That was a coal mine that I was in. Yeah, they have lots of coal in Africa. That is actually in South Africa that I was at. Zimbabwe, they do platinum mining. So there's some gold mines in Africa as well. So all kinds of different mining there. Any other questions?
Any other questions for Bobby? All right. First off, Just on a side note, Bobby actually wasn't scheduled to speak this week. There was another speaker who dropped out at the last minute, and Bobby agreed to come in, so I am very appreciative of him being willing to come in and present on Friday. Before we close things out, just a few housekeeping items. Number one, we did a head count, and I guess there's still some folks that might have forgotten to sign in, so I left one of the sign-in sheets up there. But do please remember to sign in. Your attendance is a significant portion of the grade, so make sure you're doing that. Second, I know that things happen. Like if a class goes over, or if you've got athletics or whatnot, but try and be on time. The speakers they're taking time out of their work day to come and present, so please try and be on time. One final note, I have class right before this, so I received a number of emails that I wasn't able to check until now, but I've had a number of students email me that they had problems with the quiz, like I guess the quiz closed on them. Just so everybody's aware, I mean, it's the same every week, but the quiz closes at 11 a.m. every week. Now, if there's a problem that 100 of you are facing, it's probably a problem with the quiz, and I can tweak it for the class. But if like one or two of you forget to take the quiz or whatnot, or you're taking it late and you run into computer issues, there's not a terrible amount of things I can do from my end to affect one grade. So please make sure you're taking the quizzes on time. Okay. All right. That's all I have for you all this week. You all have a great weekend. We'll see you next week. Thank you again very much.